In this video, we're going to work on adding fractions with like denominators. So this whole foldable looks over adding and subtracting fractions with like denominators. Like denominators just means that they have the same number on bottom. And so when we add fractions with like denominators, you can make a long fraction bar. So we're going to put equals, and we're going to put our fraction bar. We keep the denominator, which is 8. And then you can write the numerator as one problem on top. So 5 plus 8 is what we can put on top here. And we know that 5 plus 1 is 6 over 8. And then we have to reduce. And reducing should be a review skill, but if it's not, I'll just remind you, when we reduce fractions, we want to ask ourselves, is there a number that goes into both 6 and 8? And in this case, the number 2 goes into 6 and 8, so I'm going to divide top and bottom by 2. When I divide top and bottom by 2, I'm dividing by 2 over 2, which is dividing by 1. And when we divide by 1, any number divided by 1 is still itself. So that's why we know these are equal, but it's in reduced form. It's in simplest form. So 6 divided by 2 is 3, and 8 divided by 2 is 4. So my reduced answer is 3/4. And then it says if the answer is an improper fraction, convert back to a mixed number. So in this case, 3/4 is not an improper fraction because the top number is smaller than the bottom number, or the numerator is smaller than the denominator. Check the sign of the final answer. Should it be positive or negative? In this case, we had a positive plus a positive, so same signs, add and keep, and my answer is 3/4. On this next one, we've got 11/12 plus 9/12. So I can put my equal sign, and I can do 11 plus 9 on top over the denominator, which stays the same of 12. 11 plus 9 is 20, and 20 is over 12. I can choose to reduce first, or I can choose to change to a mixed number first. Because this is an improper fraction, it has the numerator is bigger than the denominator. It is improper, so you can do either way. I like to reduce first, so I'm going to reduce this and ask what number goes into 20 and 12, and the answer to that is 2. So 20 divided by 2 is 10, and 12 divided by 2 is 6. When I did that, I realized, ooh, there was a bigger number than 2 that could have gone into them, because 10 and 6 can still be reduced. 2 goes into both of those. So if I look back, I could have divided by 4 originally, or we still get to the same answer, 5/3. But once we get our answer in simplest form, we have to change it to an improper fraction. So 3 goes into 5 one time with a remainder of 2, so 5/3 changes to 1 2/3. And then our answer, a positive plus a positive, same signs, add and keep. So I keep the positive sign. 11/12 plus 9/12 is 1 2/3. On this next set, we've got -7/12 plus 1/12. Same signs, add and keep, but different signs we have to actually subtract. Since we've got a negative and a positive, we're actually going to do 7 minus 1, which is 6. Keep my denominator the same. And my negative is bigger, same signs, add and keep, different signs, subtract. So 7 minus 1 is 6. Keep the sign of the higher number. In this case, that's -7, so this is -6/12. And now I just have to reduce. And I know that 2 goes into both of these, 3 goes into both of these, and 6 goes into both of these. The higher the number, the quicker we can reduce. So I'm going to divide top and bottom by 6 here. And when I do that, I get -1/2. So -7/12 plus +1/12 is equal to -1/2. At this time, I would challenge you to pause the video and try this one on your own, and then come back to check your work. So for this next one, we've got -5 plus -2 over 21. And negative plus a negative, same signs, we add and keep, so that's -7 over 21. My denominator stays the same. And then the last thing that I need to do, because it's not improper, I don't need to change it to a mixed number, but I do need to simplify because 7 goes into both of these numbers. And so 7 divided by 7 is 1, and 21 divided by 7 is 3. Our answer was negative, and so all of this is equal to -5 and 5/21 plus -2/21 is equal to -1/3.